Hey everybody, welcome to another chemistry video lesson. Today's video lesson is going to start our topic of chemical bonding. So I'm going to briefly talk about what chemical bonds are and then get into our first type of chemical bond, which is the ionic bonding. So far we've been talking about atoms and how the atoms are all coming together and stuff and what the components of the atom are. Now what we're going to start doing is we're going to start taking those atoms that we have, something like the oxygen atom that we've used before. We're going to take this oxygen atom, this atom of oxygen, we're going to bond it with something like hydrogen atoms. Okay, so we've talked about what these oxygen and hydrogen atoms are made up of, but now what we're going to do is we're going to start putting them together and start creating various compounds. So oxygen is going to bond with hydrogen and it's going to make a water molecule. You guys hopefully are familiar with water. So you get your water molecules based on one oxygen bonding with two hydrogens. So what you end up with is a compound. So compounds are when two or more atoms join together to create other compounds. Oxygen can bond with itself, and when it does, it's going to create a compound of oxygen. We'll talk about what those double lines mean a little bit later, but that would be an oxygen molecule. We would also have a hydrogen molecule. So we can have hydrogen bonding together, creating a molecule of hydrogen. So when we write these compounds, we need to have a way of writing the formula so we don't have to keep drawing pictures all the time. We want to have a notation to represent those. So this is where the chemical formulas come in. And the chemical formula is a representation of our molecules and compounds that we're going to be creating. So this would be our formula, chemical formula for water. It tells us that there are two hydrogens and one oxygen atom in our molecule, our single molecule of water. Over here I would write this as O2 as our compound, our formula, and for our compound of hydrogen I would write that as H2. So the numbers on the bottom tell us how many atoms there are in each of them, the particular compounds we're talking about. Now there's the force here that I'm drawing as a line is called the chemical bond. And the chemical bond is the force that holds the atoms together in the molecules and the compounds that we're going to be talking about. So the types of bonds that we're going to be looking at differ. So there's obviously different bonds. There's an ionic bond, there's a covalent bond, and a couple other types of bonds. But for right now we're going to focus on just those. So the bond is what holds the atoms together, and those bonds are really what dictate what kind of compounds that we're going to have. So our first class of compound we're going to look at is the ionic compounds, okay, or ionic bonds. So our first kind of compound we're going to talk about is the ionic bond. Okay, so we've already talked about ions in the past. So just to recap, ions are formed when atoms are going to gain or lose electrons. So we're going to put a name to these. When an atom forms a positive ion, we're going to call that ion a cation. All right, and if it forms a negative charge, we're going to call it an anion. So when we looked at our metals, we said that the metals tended to lose electrons. So if metals tend to lose electrons, right? So when this sodium ion forms, it's going to lose an electron. Remember, sodium's not very good at holding onto its electrons due to the weak pull of the electron by the nucleus. And the electron moves over to chlorine. So before we talked about ions forming, but we never talked about why they form. And the reason they form is that when we take an element like sodium and we put it near an element like chlorine, chlorine has a really, really strong ability at pulling electrons because it's really, remember, the nucleus is really strong, so therefore it's going to be really good at pulling electrons. So therefore this electron is going to come from the element that's weak at pulling electrons, and it's going to go towards the element that is decent at pulling electrons, and in this case, chloride. So what we're going to end up with is we're going to have an ion form. So we're going to have an anion form on this side with a negative charge, and over here we have that positive charge, the cation, which is formed. And it's the positive ion and that negative ion that are then going to attract each other and create our ionic bond. So the ionic bond forms after the electron is transferred, and the positive, right, that positive and negative charge are going to attract each other to create our ionic bond. So it's the ionic bond that is holding our ions together. And the only way ionic bonds can form is if ions are being formed as a result. Now, if you remember what we talked about before with the periodic trends, most of the metals tend to lose electrons, so they're going to form cations. Our nonmetals are going to form the anions because they're going to gain the electrons. So for ionic bonding, what we're always looking for are metals and nonmetals. That's going to be our identifying feature here. So whenever you see a metal bonded with a nonmetal, you're going to know that it's an ionic bond. Okay, so we will have something like sodium chloride, metal, nonmetal. That would be an ionic compound. What that means is that that has a sodium ion and a chloride ion that are bonded together to create that compound called an ionic compound, because it's attracted by the positive and negative charges. So let me show you another example here. Okay, show you some other things we can do. So instead of writing these out as charges and ions, or I'm sorry, with the rings and the electrons and the dots, we need to have a simpler way to deal with this. Now keep in mind that the only electrons that really took part in this reaction are the valence electrons. They're the only ones that jumped back and forth. So we want as a shortcut notation for looking at those electrons and how they jumped around. So what we can do is we can look at our ionic compound forming. It's going to be based on the electrons. So instead of drawing sodium with all of those rings, we know that sodium has one valence electron, while chlorine has 1, 2, 3, 4, 5, 6, 7. So we're just going to represent the electrons with dots. So our dots are going to represent the electrons around each of those atoms. So what we're going to say is, okay, sodium is going to lose this electron, and it's going to go over here to chlorine. As a result, we get a positive charge on sodium, and we get a negative charge on chloride. Then we can say, okay, the positive and the negative attract each other, and we get sodium chloride. Now with magnesium, all right, magnesium has two valence electrons because it's an alkaline earth metal. Remember last chapter we kind of talked about valence electrons being predicted from the periodic table. And chlorine still has those 7 valence electrons. So what will happen here is the electrons again are going to go from the metal. So it's going to go from magnesium to chlorine. It's going to fill in the spot. Now the problem is chlorine is now filled up. So what I need is a second chlorine to fill in that second electron. We'll go over this a little more in class and stuff, but for now, the electron is going to move over to here, and what you end up with is another chlorine. So when magnesium bonds with chlorine, I need 2 of those chloride ions to actually bond with magnesium. Okay, so sodium positive 1, chlorine minus 1. We only need 1. We got to balance the charges. All of our ionic compounds are going to be neutral, but keep in mind that they're made up of charges, of ions that are bonded together. So for something like magnesium, because it's a 2+ charge, and there's 2 chlorine ions, we can add those 2 negatives. That makes it overall -2, and over here +2. Those balance out and give us a net result of a 0 charge. Okay, so if I have aluminum 3+, and I have a chloride, can you think about how many ions of chlorine that we're going to need to balance this out? You're going to need a total of 3 of them, because you have -1, -2, -3. We have to balance our charges. So that means aluminum is going to lose electrons to each one of those. Now, again, we'll go over this more later in class, but for now, that's essentially how we write our formulas and get our formulas are from those charges being balanced. Now, as a result of this, what happens with our ionic compounds, which are always formed between a cation and an anion, is we're going to create a really strong bonding force between these. Because of the fact that we have a positive negative attraction force, we're going to get really strong attraction forces in here. And as a result of that, we end up with a solid at room temperature. Okay. Now, one of the things that can happen when we put this into water is that sodium chloride will dissolve. And what that is going to allow to happen is those ions are going to be free to come out and move around in solution. And that's going to allow us to have conduction of our electric current. And I'm going to go over that part more in class. We'll talk more about that as a demonstration. But for now, just get the general idea of how these are forming and what the basic components are. Okay, so that pretty much ends the introduction to ionic bonding. As a recap, just keep in mind that the biggest things here are the fact that we form ions, and it's those ions that will then mutually attract each other with their positive and the negative attraction forces. And as a result of that, what they will then do is they will create our ionic compounds. And those ionic compounds have to balance the charges so that we have no overall charge left over, because in order for the bonds to form, electrons have to transfer. And electrons are going to transfer where they leave one positive or negative. They're going to keep transferring until everything is balanced overall. So all those electrons are accounted for and are fitting in some spot. And the other thing to remember is that it's always a metal with a nonmetal. a metal and a nonmetal that go with it. Because remember, our metals tend to lose and become our cations, and our anions are formed from the nonmetals that tend to attract the electrons. Okay, so I hope that is a good introduction, and I will see you guys later.